Tonight, we will present the data question of 2008 KCSE Biology, Paper 2. And my opening remarks are as follows. Have you ever wondered how plants balance water intake and loss during the day, especially under the scorching sun? What if I told you this secret could explain why your garden plants wither by noon? This sunflower experiment holds the key to understanding one of the most essential processes in plants: transpiration versus water absorption. Let us dive into it. The value you gain by watching this video. By the end of this video, you'll not only be able to tackle similar KCSE biology data questions with ease, but you also understand how plants thrive in their natural environments by managing water intake and loss. This will give you a big advantage whether you are preparing for exams or growing your own plants at home. Stay tuned and you'll gain insights into solving these complex graphs and understanding what they reveal about nature. Skills that will serve you both in the classroom and in real life situations. My brief introduction to the topic. In today's video, we are going to break down a real-life KCSE biology question that investigates the fascinating balance between water absorption and transpiration in sunflowers. We will plot graphs, analyze data, and find out how these plants manage water during different parts of the day. Whether you are aiming for a top grade or just curious about plant biology, you won't want to miss this. Get your pens ready because we are diving deep into data interpretation and graph plotting, something that's crucial for biology exams. Let's explore how sunflowers manage their water needs throughout the day. It's a life skill and exam strategy rolled into one. This video is for viewers who are curious about plant biology, preparing for exam, or simply interested in learning how to analyze scientific data. Welcome to the video. 2008 KCSE Biology Paper 2. Data question was number 6. And you are getting 20 marks. An experiment was carried out to investigate transpiration and absorption of water in sunflower plants in their natural environment with adequate supply of water. The amount of water was determined in 2-hour intervals. The results are shown in the table below. Before we delve on it, I would also like to say this, that this data question serves to make concepts learned in theory clearer, motivate further thinking, and make biology relevant in day-to-day living experience. This video is designed to develop the ability to do guided manipulations, paying attention to the importance of step-by-step approach, understanding the procedure, examining the data, and making the correct observations. Plotting the data after carefully choosing the correct scale, drawing smooth curves with free hands, and making the right decisions to answer the questions using information given in the data and the graph. The video will not be of any help if the equations are not done and the work is treated through theory approach. You develop analytical skills by practicing them. This is the only way you will become aware of your strengths and weaknesses in biology. So that one is free advice, guys. So that is your table. Time of day, amount of water in grams. All right, time of the day, we started from 11 to 3 p.m. And you can see the various data. 11 to 13, we had transpiration. The amount of water was at 3 grams. All right. Absorption was 20. 13 to 15, 45, 30. 52, 42. 15 to 17. 17 to 19, 46, 46. They were equal. That's around 5 and 7 p.m. 19 to 21, 25, 32, 21, 23, 16, 20, 23 to 1 a.m. That is 11 in the night. You are the 16, 20, 08, 15, sorry, and 1 to 3 a.m. You are the 04 and 11. Questions. Using the same axis, plot graphs to show transpiration and absorption of water in grams against time of the day. You get 7 marks. At what time of the day was the amount of water the same for transpiration and absorption? 1 mark. Account for the shape of the graphs. Account for transpiration. And then you account for the shape of the absorption. You get 3 marks each. What would happen to transpiration and absorption of water if the experiment was continued till 5 hours? You get 2 marks. Name 2 factors that may affect transpiration and absorption at any given time. Explain how the factors you named in E above affect transpiration. So here, guys, this is where I was saying you do it first yourself. You don't just look at the video, practice. You can practice and then proceed with the video. To plot graphs for transpiration and absorption of water in sunflower plants against time of the day, follow these steps. And identify the variables. You identify the independent variable, in this case is time of the day. Dependent variables, in this case is amount of water transpired and absorbed in grams. Number 2, determine the scale, x-axis, which is horizontal axis. This will represent the time of the day. So each interval, 11 to 13, 13 to 15, should be evenly placed. Y-axis or vertical axis. This will represent the amount of water in grams. You should select a scale that accommodates both transpiration and absorption, ensuring that the highest value, 52, fits on the graphs. For example, you could use a scale of 1 unit represents 5 grams. Number 3 is drawing of the axis. X-axis, label this axis as time of day and mark intervals for the given time periods, 11 to 13, 13 to 15, etc. Y-axis, label this axis as amount of water in grams and mark values from 0, slightly above the highest value, which is 52. A good range might be 0 to 16 grams. 4. Plot the points. Transpiration. For each time interval, plot the value of transpiration on the graph. For example, 1100 to 1300, you plot the points for 33 grams. 1300 to 15, plot 45 grams, and so on. Absorption. On the same graph, plot the values of absorption at the corresponding time intervals. For example, 11 to 1300, you plot 20 grams at 1300 to 1500, plot 30 grams, and so on. 5. Connect the points. Connect the points. Use smooth lines to connect the points for transpiration and absorption separately. It is common to use different colors or types of lines, solid for one and dashed for the other, to distinguish between the two sets of data. And a region or a key to differentiate between the transpiration and absorption line include a key or agent indicating which lines represent each variable. But you can also identify the line in the graph where you write transpiration and absorption. 6. To differentiate between transpiration, lines include key or agent indicating which lines represent each variable. Title the graph, and an appropriate title such as transpiration and absorption of water in sunflower plants throughout the day. Example, graph explanation. You observe that both transpiration and absorption increase during the day, with transpiration peaking between 1500 to 1700 hours and absorption peaking slightly later, around 17 to 1900 hours. After sunset, both processes slow down, with the transpiration decreasing more sharply than absorption. Once you finish the graph, you'll be able to visually compare the trends of transpiration and absorption over time. So that is the graph paper. where you first draw the X and the Y axis, then you do the necessary as advised above there. And that is your final graph. Graph to show transpiration and absorption of water in grams against time. Time of the day down there, and absorption to water in grams. Then you have the times 1300 to 1500, 1500 to 1700. You see they are in this equal intervals. Then we start from 0 to 60. All right. Marking of the graph. You can see plotting P will give you 2 marks. Curve will give you 1 mark. Identity will give you 1 mark. Axis, you have a mark labeling, and labeling again axis, you get another mark. Scale, you get a mark, and the other scale, you get a mark. How to mark the graph? Curve must be continuous. If axis is reversed, mark scale only one mark for identification. Yeah, maximum will be 1 mark for scale and for identification. Separate graphs, mark then first one. No, mark the first one, sorry. There's a problem there. Maximum 5 marks. Scale 2 marks, curve 1 mark, axis 1 mark, plotting 2 marks, all correct. Identification 1 mark. At what time of the day was the amount of water the same for transpiration and absorption? That was 17 to 1900 hours. Account for the shape of the graphs. Transpiration 11 to 17, rapid increase in the rate of transpiration due to high light intensity or high temperatures. 17 to 3 hours, decrease in the rate of transpiration. 4 marks maximum. Account for the shape of the graphs. Absorption 11 to 1900, increase in the rate of absorption of water to replace water lost through transpiration. 0 to 19 hours to 13 hours, decrease in the rate of absorption of water due to the fact that the rate of transpiration has declined. What would happen to transpiration and absorption of water if the experiment was continued till 5 hours? Both transpiration and absorption decrease. Name 2 factors that may affect transpiration and absorption at any given time. These are the wind, humidity, atmospheric pressure, light, and temperature. Explain how the factors you have named in E above affect transpiration. For wind, the rate of transpiration is faster when it is windy, lower when the air is still. Humidity, when humidity is low, the rate of transpiration is faster due to diffusion. When it is high, rate of transpiration is lower. Atmospheric pressure. The rate of transpiration is higher at low atmospheric pressure due to high diffusion gradient between intercellular species and the atmosphere. At high pressure, the rate is low. Right. At high rate intensity, the rate of transpiration is low. Temperature. At this high temperature, transpiration is high, and at low temperature, transpiration rate is low. So I also give a computer-generated graph just to show you the difference, where I was talking about a broken line, the other one being solid. The color of one is blue and the other is green. Then up there you have got the rigid or the key, transpiration, absorption. Time of the day down there. You can see the time intervals are equal. Then you have 10 to 50 as your highest mark, because the highest mark is 52. So that's just a computer-generated graph. Interpretation of the graph. Here, the graph showing transpiration and the absorption of water in sunflower plants over the course of a day as observed. Transpiration increases during the early afternoon, reaching a peak at 15,700 hours, and then decreases steadily until the early morning. Absorption shows gradual rise from the 11 to 13 hours, peaking at the same time as absorption, 17 hours to 19 hours, followed by a decline during the night. This data visualizes the relationship between water loss and intake in plants during a day, which can help in understanding how sunflowers manage water under different environmental conditions. Here is how it translates into real-life world. One is data interpretation. Understanding how to read and interpret data tables and graphs is essential in various aspects of life, such as analyzing weather patterns for those in the meteorological department, monitoring health statistics for those in hospitals, or even reviewing financial reports for those who are in the banking sector or SACCOs. Problem solving. The skill of identifying patterns, such as understanding when transpiration is highest or how water absorption fluctuates, can enhance your critical thinking. It applies to decision-making scenarios in gardening, agriculture, and environmental management. Graph skills. The ability to draw and interpret graph is a useful skill in any profession that requires data visualization, whether in business, research, or even day-to-day tasks like tracking household expenses or fitness or progress. Scientific understanding. Grasping the science behind natural processes such as transpiration and water absorption gives insight into larger issues like sustainable agriculture, water conservation, and the effects of climate change. This content, while rooted in biology, equips viewers with key analytical and problem-solving skills useful across many daily lives. We cannot end the video without acknowledgements and video credits assisted by ChatGPT, an AI developed by OpenAI. But I'm grateful to all the individuals who commented positively when the final video was launched, and the third party whose material has been used in this video. Bye and see you in my next academic video.